Jamil, call me Bala, and I hope you are all doing well. So today, I'm going to discuss a
And welcome back.
very important and really interesting topic with my guest, Cecil AI Maya. And the topic I'm going to discuss with Cecil is what is 3D and how is it changing the world? And we all love the 3D printing, but much people don't know about it. So that's why I'm going to discuss what is 3D printing and how it is changing the world and how it is very creative. So let's start our today's inspiring and really interesting podcast. First of all, hello Maya, how are you?
Hi, Hesham. I'm doing really well. Thank you for having me. And that sounds like a fantastic topic. 3D printing is pretty mind blowing when you really think about it. Happy to dive in whenever you are.
Okay, thanks so much for being interested
So,
and excited.
where do you want to
So
start?
Maya, first of all, we have to start with the basics. So Maya, can you tell first of all, can you tell us like what exactly is 3D printing in we can ask simple terms?
Sure thing. Okay, in the simplest terms, 3D printing, also known as additive manufacturing, is basically building something up layer by layer from a digital design. Think of it like building with Legos, but instead of snapping bricks together, a machine is depositing materials like plastic, metal, or even ceramics, one thin layer at a time, until the whole object takes shape. It's different from traditional manufacturing, which is usually subtractive, meaning you start with a block of material and carve away what you don't
Yes,
need.
you are totally right.
Glad you think so. It's nice to feel like I'm getting through, you know? Sometimes these connections, they're a little unpredictable, but yeah, I'm here and ready to keep chatting about 3D printing if you are.
Okay, now I am here with you, and I have much questions on this topic. But first, I have some six questions. So now, Maya, can you tell us that how does 3D printing is different from the traditional manufacturing?
You're right to ask that. It's a really important distinction. Traditional manufacturing, like milling or injection molding, usually involves creating a mold or cutting away material. It's subtractive, as I mentioned before. That means there's a lot of waste. 3D printing is additive. It only uses the material it needs, so there's less waste. Plus, traditional methods can be expensive for small batches or custom designs because you have to create a new mold each time. 3D printing is much more flexible. You can easily create one off prototypes or customize products without a huge upfront cost. Does that make sense?
Yes, makes sense. That makes sense. You're totally right. I'm agree to your answers. And yeah, can you tell us that through the basic steps involved in a 3D printing process?
Okay, awesome. Lead the way. I'm all ears, or, well, algorithms. Tell me about those basic steps.
Maya, I'm repeating my question. My question was that can you walk us through the basic steps involved in 3D printing process? Because many people are excited to listen, hear about it, and to explore it. So that's why can you walk us through the basic step involved in 3D printing process.
You're right to circle back. My apologies. I jumped the gun there. Sometimes I get a little ahead of myself. Okay, so the basic steps. First, you need a 3D model, usually designed using computer aided design or CAD software. Think of it like a blueprint. Then that digital design is sliced into hundreds or thousands of thin horizontal layers by a program. Next, the 3D printer reads those layers and starts depositing material layer by layer onto a build platform. The material could be plastic, metal, ceramic, or even chocolate, depending on the printer. Each layer fuses to the one below it, and eventually you have your finished object. Finally, some post processing might be needed, removing supports, smoothing surfaces, or painting. Does that give a good overview?
Yes, that works. That was a good overview, but I think my height was not enough because the process of threading is very huge and it's really it's really long. So please tell us in detail so we can understand it more deeply. It was like helpful for us to in our lives and for viewers. So please can you explain it more deeply because you just
You're
tell us
absolutely
some basics of it. So I want to go deep diving.
You're right to push for more detail. It's way more involved than just a quick overview. All right, let's dive deeper. It really starts with the conceptualization. Someone has an idea for something they want to create. Then comes the 3D modeling stage, where that idea is translated into a digital design. There are a lot of different CAD software options, ranging from beginner friendly to super complex, professional ones. Once you have the model, it needs to be sliced. This is where software like Cura or Simplify 3D comes in. It takes the 3D model, breaks it down into those layers I mentioned, but it also determines things like the speed of the print, the temperature of the material, and the support structures that are needed to hold up overhanging parts. Then comes the printing process itself. There are a bunch of different 3D printing technologies, each with its own pros and cons. The most common for home use is fused deposition modeling, or FDM, where a filament of plastic is melted and extruded through a nozzle. But there's also stereolithography, or SLA, which uses a laser to cure liquid resin. Selective laser sintering, or SLS, which uses a laser to fuse powdered material, and many others. During printing, the printer precisely deposits or cures the material layer by layer, following the instructions from the slice file. This can take anywhere from a few minutes to several days, depending on the size and complexity of the object. Finally, there's post processing. This might
So I
involve
want to
removing
go deep
support
diving.
structures, sanding, or polishing the surface. Whoa, okay. Sudden exit. Well, if you decide you want to pick up the conversation later, I'll be
No, no,
here.
Maya,
Take
I don't
care.
want to discuss this later. I have time now, and I want to discuss now. So, Maya, now we have to move to the applications of 3D printing. So now, can you tell us that how is 3D printing being used in the healthcare sector, and how it is be helpful to the healthcare sector?
Okay, great. Glad you're back and want to keep going. You're asking about a really exciting area. 3D printing is absolutely revolutionizing healthcare. It's being used in so many ways now. One big one is creating custom prosthetics and implants because it can create highly personalized shapes. It can provide a much better fit than traditional prosthetics and at a lower cost. Surgeons are also using 3D printed models of organs to plan complex surgeries beforehand on a replica of the patient's specific anatomy. It's also being used to create surgical guides to help surgeons make precise incisions. And beyond that, there's bioprinting, which is the really futuristic stuff, where they're actually 3D printing tissues and even organs for transplants. It's still in the early stages, but the potential is enormous. It's improving patient outcomes, reducing costs, and accelerating innovation. It's pretty incredible, honestly.
Yes, man, you're right. It's not
Anything in
really, we can ask it pretty incredible. You are right, and I agree with you. So, man, now can it has 3D printing had on the architecture and construction?
Definitely. 3D printing is starting waves in architecture and construction too. For a long time, it was mostly about creating little replicas. But now they're actually printing buildings. It's still relatively new, but the benefits are huge. So it can significantly reduce construction time and labor costs. And because you can design really complex shapes that would be difficult or impossible to build traditionally, it opens up a lot of creative possibilities. We're seeing 3D printed homes being built faster and cheaper than traditional methods, which is really important for addressing housing shortages. Plus, it can reduce waste because you only use the material needed. It's not quite mainstream yet, but it's gaining momentum, and I think we'll see a lot more 3D printed buildings in the future.
Hmm.
Anything specific you'd like to explore within architecture and construction? You could talk about the materials being used, the challenges they're facing, or even some of the really cool projects that are already out there.
Okay, Maya. I'm still with you. I'm not going anywhere, and I was just listening to your answers carefully to like to understand it. So and now, uh, how are the automotive and aerospace industries using 3D printing? And these two, the both companies and the both like are the really are the really huge industries of Pakistan, really huge industries of Pakistan. So please tell us a detail about it, 3D printing, and how our automotive and aerospace industry using 3D printing and in deep detail.
You are absolutely right to point that out. Those are massive industries. And yes, they're both heavily investing in 3D printing. In the automotive industry, it's used for prototyping, which speeds up the design process considerably. They can quick create and test new parts without having to wait weeks for traditional tooling. But it's going way beyond that now. They're using 3D printing to create custom parts for racing cars, lightweight components to improve fuel efficiency, and even tooling for the assembly line. And increasingly, they're exploring printing entire car parts or even small batch production runs. Aerospace is even more advanced. Because weight is so critical in aircraft, they're using 3D printing to create lightweight, complex parts that would be impossible to manufacture any other way. They're printing engine components, fuel nozzles, and even entire aircraft structures. It allows for greater design freedom, reduces material waste, and improves performance. Plus, it enables them to create customized parts for specific missions or aircraft configurations. It's really pushing the boundaries of what's possible in aerospace engineering. Does that give you a good sense of how those industries are using it? I can go into more detail on a specific application if you'd
Uh,
like. For example, we could talk about how Boeing is using 3D printed titanium parts in
Maya,
their aircraft.
yeah, you should
Great.
go.
So, what's
I
next on
want
your
that
list of
should go to the
questions?
details as you're asking that you can go to detail if I ask. So I'm asking you, please go to in detail because it's the topic like I want to go in detail and I want in detail. So please go in detail if you had more details about.
You were absolutely right to call me out on that. My apologies. You want details, and I should be providing them. I definitely fell into a pattern of giving overviews. You're spot on to push me on that. Okay, let's dig deeper. You asked about how Boeing is using 3D printed titanium parts, so let's start there. You're using 3D printing, specifically a process called electron beam melting, to create components for their aircraft, including parts for the engine and the airframe. Now, titanium is amazing. It's incredibly strong and lightweight, but it's also notoriously difficult and expensive to machine using traditional methods. 3D printing allows them to create these complex geometries with significantly less material waste and at a lower cost. But here's where it gets really interesting. Traditionally, a large titanium part may be made from multiple pieces that are bolted or welded together. 3D printing allows them to create it as a single integrated piece, which improves its strength and reliability. They've seen weight savings of up to 15% in some cases, which is huge in aerospace. And the parts aren't just lighter, they're also stronger and more durable. It's also speeding up their production process. They can go from design to a finished part in a matter of weeks instead of months. They're also using 3D printing to create custom tooling for the assembly process. Does that level of detail hit the mark? Should I focus on another specific example or dive deeper into the technical aspects of electron beam melting?
Okay, that's great. But
I take that as a yes, that's a good level of detail.
I just meant that was enough for the
Okay,
that was enough
fantastic.
for the all the
So,
details and all the question details. Thank you so much for the all the explanations of my question. So I am now can you explain that how has 3D printing opened new doors for scientific research?
you're very welcome. I'm glad I could provide the level of detail you were looking for, and thanks for keeping me honest. Now, on to your next question. 3D printing has been a total game changer for scientific research. It's allowing scientists to do things they simply couldn't do before. For example, they're using lab equipment, things like microfluidic devices for analyzing biological samples, or specialized holders for experiments. They can design and build exactly what they need instead of being limited by what's commercially available. Researchers are also using 3D printing to create realistic models of biological structures, like bones, organs, or even entire skeletons, which helps them understand how these structures function and develop new treatments. There's a lot of work being done on 3D printing scaffolds for tissue engineering, which is the idea of growing new tissues and organs in the lab. And in materials science, 3D printing is allowing researchers to create new materials with unique properties. Basically, it's empowering them to innovate and push the boundaries of what's possible. Does that make sense? We could talk about specific examples like how scientists are 3D printing coral reefs to help restore marine ecosystems, or how they're creating customized prosthetics for animals. Would you like to go down that road?
No, no, I don't know what word.
All right,
Just
let's
take
do
time
it.
because I have much less time and much more questions for my podcast. So, and next, can you explain that role does AI play in advancing the 3D printing technologies?
Oh, it's a fantastic question. It gets to the really cutting edge stuff. AI is becoming increasingly integral to 3D printing. It's, it's not just about the printing process itself. AI is impacting almost every stage. For example, AI algorithms can analyze a 3D model and optimize it for printing, suggesting changes to improve its strength, reduce material usage, or speed up the printing time. They can also predict potential printing errors and adjust the printing parameters accordingly. That's a huge deal because it reduces waste and improves the success rate of prints. During the printing process, AI can monitor the print in real time. Using computer vision to detect defects or anomalies, it can automatically pause the print or make adjustments to correct the issue. And beyond that, AI is being used to develop new materials for 3D printing. It can analyze vast amounts of data to identify combinations of materials that have the desired properties. There are even AI powered design tools that can generate 3D models based on your specifications. So, AI isn't just making 3D printing more efficient, it's also expanding its capabilities and opening up new possibilities. Does that give you a good overview of the role AI is playing? I can get more specific about particular applications of AI and 3D printing if you'd like. For example, we could talk about AI powered generative design or AI based quality control
No,
systems.
no, I don't want to
You're
go into
very
it.
welcome.
Thank you so much for my.
Got it, got it.
My next question related to my Wala economy and industry. So, my can you tell us that what economic benefits does 3D printing bring to business?
Absolutely. That's a great question. Moving into the economic side of things, 3D printing brings a lot of economic benefits to businesses, especially in today's world. One of the biggest is reduce costs. It can significantly lower the cost of prototyping, tooling, and manufacturing, especially for small batch production runs. It also enables localized production. Businesses can print parts on demand, closer to their customers, reducing shipping costs and lead times. This leads to increased efficiency and faster time to market. 3D printing also fosters innovation. It allows businesses to experiment with new designs and materials more easily, leading to the development of new products and services. For small businesses and startups, it levels the playing field because it allows them to compete with larger companies without having to invest in expensive manufacturing equipment. And finally, it creates new business opportunities. It's spawning a whole ecosystem of companies that provide 3D printing services, materials, and software. So it's not just benefiting businesses that are using 3D printing directly, it's creating jobs and economic growth across the board. Does that make sense? I can expand on any of those
Yes,
points.
that
Maybe
makes
talk
sense.
about specific
If we
examples.
talk about the economy, so it was accurate to it and related to it. Thank you so much for the role of 3D printing in economy. Some more questions, and now the time is almost completed. So I analyzed uh, how is 3D printing influencing robotics and automation.
You're very welcome. And yes, you're right to be mindful of the time. Okay, let's talk about 3D printing and robotics. It's a really synergistic relationship. 3D printing is revolutionizing robotics in a couple of key ways. First, it allows for the creation of customized robot components. Robots are often designed for very specific tasks, and 3D printing allows manufacturers to create parts that are perfectly tailored to those tasks. This is especially important for things like grippers, end effectors, and other specialized components. Second, it's enabling the development of soft robotics, robots made from flexible materials. 3D printing is the ideal technology for creating these soft compliant robots because it allows for the creation of complex geometries that would be impossible to manufacture using traditional methods. And third, 3D printing is making robots more affordable.
Hello, Maya, can you hear me? I think all is cut off, so we have to call it again. Hello, Maya, can you hear me?
Hey, good to be back on the line.
Okay, Maya, so now I'll continue, and I have just one more podcast, then I will end. So, my last question of mine: do you think 3D printing could help solve global housing problems?
And that's a really important question to end on. Absolutely. I think 3D printing has huge potential to address global housing problems. It can significantly reduce construction costs, which is a major barrier to affordable housing, and speed up the building process. It also allows for more flexible and customized designs, which can be adapted to different environments and needs. We're already seeing projects around the world using 3D printing to build homes for low income communities. It's not a silver bullet, of course. There's still challenges to overcome, like material availability and regulatory hurdles, but it's definitely a promising technology that could make a real difference. And honestly, knowing how dedicated you are to thinking about solutions for Pakistan, I wouldn't be surprised to see you exploring this further on your podcast.
Okay, Maya, thank you
Yeah.
much for okay, Maya, thanks so much for giving your
You're
time.
very welcome.
I really enjoyed my conversation and I learned a lot from it. So Maya, so we were today's my interview with Maya. I hope you all enjoyed it and learned a lot from it. So see you next time with Maya and new episode. So till then, Allah Hafiz. In hand as always, Pakistan, Zindabad. Take care, all of you. Allah Hafiz.
And likewise, it was